Reg Skill Check, Part B, number 4. So we have a paragraph of information that belongs to questions 1 through 3. So, first question, based on the information given, identify the direction of heat flow when the cold pack is activated and applied to the body. So, heat always flows from the warmer object to the cooler object, okay? And the human body is approximately 98 degrees Fahrenheit, and the activated cold pack has a temperature of around 2 degrees Celsius, so human body is about 37 degrees Celsius. So 37 degrees Celsius is warmer than 2 degrees Celsius. So in this particular example, heat flows from the body to the cold pack. Okay? Now, take a look. It says in question 2, identify both types of bonds in this structure. So that means we need 2 answers. So take a look. We have types of bonds. There's the metallic bond, where it's all metals. We have an ionic bond that we typically recognize as a metal plus a non-metal, or a compound with a poly. And then we have a covalent, which is all non-metals. So these are our 3 major types of bonds. So when we take a look at this compound, we notice that there are more than 3 types of elements. There's nitrogen, hydrogen, and oxygen. So that means that we have a polyion present. And in fact, we have 2. The first poly is NH4, and our other poly is NO3. So what links the nitrogen and hydrogens within the NH4 poly is all nonmetals. So that means within the poly we have covalent bonds. So that's what holds the poly together. But then it is a polyatomic ion bonded to a partner. So since it's a polyatomic ion, that means linking the NH4 to the NO3, that's the ionic bond. So we have covalent and ionic. So this is what links the 2 poly ions. Covalent within the poly, ionic linking the polys. Okay? Now number 3, identify the type of mixture. We have 2 major types of mixtures. One is homogeneous and the other is heterogeneous. So HOMO is the idea of same, HETERO is the idea of different, okay, to remember, and it talks about the distribution of the particles. So if something is completely dissolved, you should think of the term solution. So anytime something for us is described as a solution, it automatically falls into the homogeneous realm. So the best answer, the type of mixture form, is a homogeneous mixture. Okay? And now we have questions 4 through 6 are based on this set of questions, or that paragraph of information. So it says, number 4, write the balanced equation for the reduction half reaction. So a quick reminder that think about oxidation numbers. If your oxidation number from beginning to end increases, that's your Leo process, oxidation, losing electrons. If your oxidation number reduces to a lower charge, that's the Ger process, gaining electrons, being reduced. So you have to go through the reaction and quickly assign. So I see oxygen, it's not a peroxide, -2, 1 ppb, so that's a +2. I have an oxygen, not a peroxide, -2, so this carbon must be using a +2. I see Pb, it's a pure element, so I assign it a charge of 0, and then I see I have carbon again, ends in O2, possibly a peroxide, but C is not from group 1 or 2, not a peroxide, so oxygen's a -2, and it takes 2 oxygens to balance out the charge of the carbon, so that means a +4. Now when I look left to right, I see that every oxygen, no matter what substance or side, it's a -2, so it's a spectator, ignore it. So if I look at my info, I see I have a Pb that goes from a +2 to a Pb0, and then I also see that I have a carbon that starts off with a +2 and becomes a +4. But I need the reduction, so that means I need one that shows a reducing or a more negative oxidation number. So I have to write the half reaction for this guy, for the leads. This is GR, the other one is the oxide, but I don't want to show anything about it, so I'm going to ignore it. So Pb plus 2 becomes Pb0. Notice, my count of Pb's is the same, but on the left I have a +2 charge, and on the right I have a 0 charge. So the charges are not balanced or showing conservation yet. The way we balance charges is by placing electrons into the half reaction. Electrons carry negative charge. So if I add 2 electrons to the left, now I have 2 times that -1 gives me a -2 plus the +2, so the total charge here is now 0, and it matches the right hand side. So this is my reduction half reaction. Now, question 5, assigning oxidation numbers. Determine the oxidation number or charge of carbon in carbon monoxide. So carbon monoxide formula is CO. I see carbon is present, it's not a peroxide, so the carbon uses a -2. It requires the oxygen, it's not a peroxide, so it uses a -2, requires 1 carbon to balance out the oxygen's charge. So X plus -2 needs to equal 0, therefore carbon must be using a +2. So final best answer is +2. Question 6. Okay, so question 6 is also based on this information. So it says, calculate the percent composition. Percent composition formula you can find on your table T. So if you have to calculate something, immediately go to your table T. And percent comp, okay, so if you go there and find it, it is the part over whole times 100%. And it wants us to do it for the oxygen in this litharge. Well, what the heck is litharge? If you go back to your reading, you'll find that term litharge and the formula that belongs to it. So I'm interested in the oxygen that is present in the litharge, PbO. Okay, so I have 1 oxygen. Its mass is 16 grams divided by the mass of the whole compound, which right here is given to us is 22.32 grams, multiplied by 100%. And notice it says we have to show both correct numerical setup and a calculated result. So this right here is a great example of a correct numerical setup. And if you plug this into your calculator, the final answer calculated result is 7.2%. And so this is the result.